We are going to discuss climate change from the viewpoint of so-called tipping points. Thinking in terms of tipping points leads to different outcomes. Thinking in terms of tipping point is to think in terms of what are called non-linear outcomes or impacts. Non-linear outcomes are impacts. What is meant by this? So there is a weight attached to the spring. If there is more weight, there is more strain. F is equal to kx. If there is more weight, there is more strain, more weight, more. But if you put something very huge, say a huge one, then this will collapse. So at what point this will collapse and at what point this equation is no longer valid refers to the tipping point of this particular spring. Okay, it means that within a particular range of force, this works proportionately. But after a particular range, after the tipping point, then it collapses. It means there is a threshold force at which this equation is no longer valid. This is the concept of tipping point. Or you can take the tipping point, concept of tipping point. For example, within this curve, if you push this ball, it will come to this and then it will come back. In the same way, as long as the ball is here, you push, it will come back. But after this point, and if you push, it will go into new state. So this is one state, this is another state. So tipping point is a threshold where this ball enters a different state. Okay. So IPCC IR 6th assessment report says tipping point is a critical threshold beyond which a system reorganizes, often abruptly or irreversibly. One aspect of tipping point is irreversibility. We can't get it back. Is it reversible? Till this it is reversible. In the same way, spring beyond a point is damaged. It is irreversible. Okay. So the idea is that Earth system is composed of certain tipping points, and under certain critical thresholds or beyond certain critical thresholds, those tipping points will be reached and one cannot go back. Okay. For example, thinking from critical points, tipping points, Earth system is seen like this. Seen in terms of certain tipping elements. Each tipping element has a tipping point. Okay. So in this, certain systems, certain process will fail when the temperature rise is between 1 to 3C. What are those points that may fail within 1 to 3C? Greenland ice sheet, melting of Greenland ice sheet. Arctic summer sea ice, summer, and it is not winter. Alpine glaciers. And next, West Antarctic ice sheet and coral reefs. Coral reefs near Australia. So these points may collapse at a certain stage between 1C and 3C. And then other tipping elements may collapse between 3 to 5C. What are those tipping elements? Boreal forest, Amazon rainforest will be hugely degraded. It is because certain changes are going to take place to air and ocean currents, changes to jet stream, thermohaline circulation, and El Nino. These changes will take place, and by which Indian monsoon also will be affected, and a part of Western Africa is going to be a huge degradation, Sahel region. So this will take place between 3 to 5C. And beyond 5C, even Arctic winter sea ice, permafrost, and East Antarctic ice sheet will collapse beyond 5C. So, in this thinking, one is not looking at a non-linear relationship with CO2 and CO2 and temperature. It is not a non-linear relationship, but rather at some places, abrupt shifts will take place. Okay. And then in what is called tipping cascade, in tipping cascade, breakdown of one element will impact another element and then another element, like this. One falls on the other. So, if you are thinking in terms of tipping points, you will think in terms of non-linear changes and critical thresholds. Okay. And you will pay close attention to the ground reality. Okay. Now, we will discuss one point that is related to Antarctica's ice sheets. Okay. Let us see how this works. This is about ice sheets in Antarctica. Ice sheet is here, ice sheet. This is on this earth, and a part of ice sheet that is projected without any earth support is called ice shelf. Ice shelf is ice sheet. And the meeting point between the ice sheet and the ice shelf is the grounding line. See, when the grounding line is like this is a stable. What does this mean? It is at a higher elevation point. So water is stopped here. Suppose this is melted, this ground is eroded, or this ice is melted and becomes like this. That is, higher elevation point is reached. Then so this one becomes easily eroded. Okay. is easy to erode. So it means that if the ice sheet is like this and the melting starts here, then it is easily eroded. It means grounding line impacts amount of melting. Impacts some amount of melting. So till some point it is resistant, and then after that huge melting takes place. Okay. So it is not that temperature hugely increased. No. It is just that it is the same continuous rise in temperature, but grounding line changed, and then melting takes place in a way that drastic changes take place. Okay. So that is why Antarctica is like this. There are so many ice shelves are there in Antarctica. This is East Antarctica, this West Antarctica, this Antarctica Peninsula. Consists of many ice shelves and some huge ones like Ross ice shelf, Roan ice shelf. And recently, some ice shelves melted. For example, in 2002, 2/3 of Larsen B ice shelf of Antarctica collapsed within 6 weeks. This ice shelf had been there for around 12,000 years. And like that, some collapsed and some greatly weakened. Why? Because the temperature is rising, water is becoming warm, and ice is melting. In February 2022, it recorded highest temperature of 18.3 Celsius. And look at the rate of ice loss between 92 to 2002, 43 gigatons per year, and between 2012 and 17, 220 gigatons per year. On the whole, total loss between 92 to 2008 was likely 2,720 gigatons for the grounded part of the ice sheet, according to Assessment Report 6. And this has huge implications. If entire Greenland ice sheet melts, total sea level, this is about Greenland, 7 meters. But West Antarctic, 5 meters. And East Antarctic ice sheet, 50 meters. So if all the ice sheets melt, it is going to be 60 plus meters. Okay. So when are they going to melt and how they are going to melt? You will have to work out ice sheets and critical thresholds, and then sudden collapse, and then sea level rise. Sea level rise. So it means you will have to work out the exact position of ice sheets, ice shelves, and critical thresholds, and then how this is going to be. Okay, so that is the actual work. And concept of critical tipping cascade will explain how things can be different.
Everybody knows about playing with dominoes, but what you may not know is that a domino can knock over another domino, which is about 1.5 times larger. So what I have here is a chain of dominoes. Each one is 1.5 times larger than the previous one. And the smallest domino is about 5 millimeters high and 1 millimeter thick. And I will carefully place it. And there are 13 dominoes. And the largest domino, it weighs about 100 pounds and is more than 1 meter tall. Ready? Boom. That was 13 dominoes. If I had 29 dominoes, the last domino would be as tall as the Empire State Building.
So it shows something very, very small can impact other. Okay, so what it means is that something like melting, Greenland ice sheet melting, can trigger a chain of events and lead to catastrophe. One need not wait for huge increase in temperatures for catastrophe to occur. Thank you.